Of you. In the last class, we have discussed about refining and reforming of petroleum. Today, we shall discuss about non-petroleum fuels. The non-petroleum fuels are nothing but liquefied petroleum gas (LPG), natural gas, compressed natural gas, that is CNG. The fourth is biogas, and the fifth is biomass. We shall discuss one by one. Liquefied petroleum gas, which is commonly known as LPG, it is nothing but a byproduct obtained during the cracking of heavy oils. It is a byproduct obtained by cracking. Liquefied petroleum gas is nothing but, that is LPG. It is a byproduct during cracking of heavy oils. LPG is dehydrated, desulfurized, and some type of organic sulfides are added in order to know the leakage in the cylinders. The calorific value of liquefied petroleum gas is nearly 27,800 kilocalories per cubic meter. The main constants of liquefied petroleum gas is mainly N-butane, isobutane, butylene and propane. It is used as a domestic fuel, industrial fuel, and nowadays LPG is used as a motor fuel. Once again, I repeat, the main constants of LPG are N-butane, isobutane, butylene and propane, which is having a calorific value of nearly 27,800 kilocalories per cubic meter. And the uses of LPG are used as a domestic fuel, industrial fuel and a motor fuel. Next, natural gas. As we all are aware that crude oil is obtained from Earth's crust by digging the Earth's crust, and the oil is sucked out of the wells. Here natural gas is always occurs along with petroleum oil in oil wells. Mixture of not mixture. If natural gas occurs along with petroleum oil is known as a wet gas. If the natural gas is associated with the crude oil is known as dry gas. Dry gas and wet gas. Natural gas plus along with petroleum oil is known as a wet gas. Natural oil along with a crude oil is known as a dry gas. Before the usage of this natural gas, we should remove some ingredients which are present in this natural gas are water, dust, sulfides, carbon dioxide, nitrogen, propane, butane, butene, etc. By removing these all ingredients, we can use natural gas. It is used as an excellent domestic fuel and the manufacture of chemicals, and it is used as a raw material for the manufacture of carbon black and hydrogen. And its calorific value is varies between 12,000 to 14,000 kilocalories per cubic meter. The approximate composition of natural gas is methane is in between 70 to 90%, ethane 5 to 10%, and hydrogen is about 3%. And the remaining percentage of natural gas is a mixture of carbon dioxide and carbon monoxide. Once again, natural gas is always present along with petroleum, either with petroleum oil or crude oil, which is obtained in wells. Natural gas along with petroleum oil is known as a wet gas, and the gas associated with crude oil is known as a dry gas. Before the usage of this natural gas, we have to remove some impurities which are present in natural gas such as water, dust, sulfides, carbon dioxides, nitrogen, butane, propane, etc. The composition of natural gas is methane 70 to 90%, ethane 5 to 10%, and hydrogen 3%. And the remaining percentage is a mixture of carbon dioxide and carbon monoxide. It is used as a domestic fuel, and it is used in the manufacture of large number of chemicals, and it is used as a raw material for the manufacture of carbon black and hydrogen. Here, the third topic is compressed natural gas, that is CNG. This compressed natural gas is nothing but the above natural gas which is compressed to a pressure of 1000 atmospheres. We get CNG. The natural gas which is obtained from wells is compressed to about 1000 atmospheres of pressure. We get CNG, that is compressed natural gas. Nowadays, this CNG is used as a substitute for petrol and diesel. Because CNG is used in place of petrol and diesel because it is compared. Nowadays, CNG is used as a substitute for diesel and petrol because it is comparatively much less pollution causing fuel. During its burning or during its combustion, no sulfur compounds and no nitrogen gases are evolved. Hence, it is a better fuel than petrol and diesel. The basic cost of a heat engine or the basic cost of an engine which is designed to be used CNG as a fuel is having a cost higher than that of a engine which is designed to use petrol and diesel. Basically, the initial cost of an engine in which the compressed natural gas that is to be used as a fuel is higher than that of an engine, than that of a cost of an engine in which the fuel like petrol and diesel are to be used. The fourth topic, biogas. Biogas is nothing but it is obtained by the degradation of biological matter in absence of free oxygen. It is obtained by degradation of biological matter in absence of free oxygen. Examples: natural gas, gobar gas, and biogas. As we have discussed in early topic, natural gas, natural gas is also a biogas which is obtained from Earth's crust. For a long period of time, the animal wastes and plant waste, vegetable matters which are buried in the Earth's crust, after a long period, the decay of animal waste, plant waste, vegetable matters which are buried in the Earth's crust, we get a natural gas from the Earth. Second example, gobar gas. Gobar gas is nothing but a cattle dung, either cow or buffalo, which is fermented in absence of air. And the third, biogas can also be produced from sewage waste and organic waste. These are all the three examples by which a natural biogas is produced. And the main constants of biogas are methane, carbon dioxide, hydrogen, nitrogen, and sulfides. The compositions are: methane is 50 to 60%, carbon dioxide 30 to 40%, hydrogen 5 to 10%, and nitrogen 2 to 6%, and a small traces of hydrogen sulfides are present in biogas. The raw materials which are required for a biogas are, as we have discussed earlier, animal dung, that is cattle dung, poultry waste, vegetable waste, plant waste, waste paper, human excreta, birds excreta, etc. The biogas is used for cooking food, and it is used as a fuel to run engines, and it is used as an illuminant in villages. This is about biogas. And the last topic is biomass. The same topic which I have discussed in biogas is related with biomass. The raw material which is used to prepare biogas from biomass is waste organic matter. For example, wood, cattle dung, bagasse. Bagasse is nothing but the waste product after the preparation of sugar from sugar cane is known as bagasse. Wood, cattle dung, bagasse, poultry waste, vegetable waste, waste paper, plant waste, human excreta, birds excreta, dead animals, sewage, organic matter. These are all the examples from which the biogas is produced. The biomass consists of carbon compounds which may be used as a source of energy by using either of the following methods. The first method is biomass such as wood, cattle dung, bagasse, plant waste, agricultural waste are all used directly for getting energy. However, by doing so, a lot of energy is wasted and a lot of smoke is also liberated. When we burn directly wood, cattle dung, bagasse, plant waste, agriculture waste, we get a lot of smoke which causes blackening of utensils. Moreover, it liberates carbon dioxide, poisonous carbon monoxide. And the second method is biomass. Biomass is also converted into biogas. In this second method, let us consider one example. If one kg of dry cattle dung liberates 1000 kilojoules of heat on direct burning, if the same amount of dry cattle dung is converted into biogas, once again, if 1 kg of dry cattle dung liberates 100 kilojoules of energy or heat on direct burning, if the same amount of cattle dung is converted into biogas, it liberates 800 kilojoules of heat on burning. The difference between the direct cattle dung, which on direct heating gives only 100 kilojoules, if the same amount of cattle dung is converted into biogas, it liberates 800 kilojoules of heat. Here, the cattle dung is nothing but a biomass. The conversion of biomass into biogas liberates more amount of heat. Okay, by this biomass, we shall make a conclusion.